With the right technology, we may be able to make our video game characters aware of their own existence. To them, their pixelated, simulated worlds would be their reality. And this idea forms the basis of what scientists call the simulation hypothesis, that perhaps we are living in a simulation. Eventually, our simulated characters may build their own simulations, and that simulation might do the same, and as the process repeats, the chance that we humans happen to be that one base reality becomes quite improbable. Pretty compelling, but it relies on the unproven assumption that we will create such technology. Instead, it will be more useful to look for clues in our own world. To understand simulation theory, we must understand what runs simulations: a computer. A computer is a machine that does simple and rapid calculations as a result of either receiving a signal, a 1, or not receiving a signal, a 0. These famous 1s and 0s are computing bits, the smallest form of information in a computer. The idea that a computer operates from these distinct, indivisible units is a concept called quantization, and it appears that our universe demonstrates this. Any distance, for example, can be measured as a certain number of Planck lengths, the minimum distance we can measure in our universe. Take a look at these Lego bricks. With these, I can have 2 bricks or 1 brick, but never 1.5 bricks. These bricks can represent computer bits or our universe's distances, since all are quantized. This idea is present in distance, light, energy, matter, so we know that it's fundamental to not only computers, but to our universe. For scientists, this overlap seems to suggest a computer-based reality. Despite the increasing complexity of video games, computers run them well, partly due to optimization. To require fewer calculations, a computer will only render or load what is being looked at on screen. But how is this applicable to our world? The Copenhagen Interpretation says that the findings of quantum physics tell us that objects don't have definite properties until they are observed. When I throw this Lego brick behind me, it could be on my right or my left or directly behind me, and the Copenhagen Interpretation says that the block assumes all of these positions in what is called a superposition until I look. Of course, throwing a Lego brick is not a scientific experiment, but scientists have put this idea to the test. In one experiment called the double slit experiment, scientists noticed that observation appears to collapse an object's superposition, making it go from that state of superposition to existing in just one point when observed. This theorized observer effect is seen by some as an example of computer optimization. Just as a computer loads what a player can see, it appears that the universe only renders an object and its properties when it knows it is being watched. The tendencies of our universe to act as a computer fuel the simulation theory, but simulation theory is just that, a theory. Regardless of its truth, it's a fascinating reminder of what we still don't know, and an example of the power of science to unearth humanity's greatest mysteries. Thanks for watching.